In programming, variables are a fundamental concept used to store, manage, and manipulate data. A variable acts as a named container that holds a value, allowing that value to be referenced and used throughout the program. The value of a variable can be updated or modified as needed, making it a dynamic and flexible tool for managing data in any computational task. Two key aspects of working with variables are the use of the assignment operator to assign values and the process of casting, which allows for the conversion of a value from one data type to another. The assignment operator, represented by the equals sign, isags, is used to give a value to a variable. This process involves specifying a variable name, followed by the assignment operator, and then the value to be stored in the variable. For example, in a program designed to calculate the area of a rectangle, you might use the assignment operator to assign the value 10 to a variable named length and the value 5 to a variable named width. The statement length equals 10 effectively tells the computer to store the number 10 in the memory location associated with the variable length. Similarly, width equals 5 assigns the number 5 to the variable width. Once a value has been assigned, the variable can be used in operations such as multiplying length and width to calculate the area. The assignment operator makes it possible to initialize variables and update their values throughout the execution of a program. For instance, if the length of the rectangle changes, the variable length can simply be reassigned a new value, such as length equals 15, ensuring the program adapts to the new data. Casting is the process of converting a value from one data type to another. This is particularly important in programming when the data stored in a variable needs to be used in a context where a different data type is required. For example, you might have a program where a user inputs a number as text, but you need to perform mathematical operations on that number. In such cases, the value stored as a string would need to be cast to an integer or a float to enable calculations. Casting can be explicit, where the programmer specifies the desired conversion, or implicit, where the programming language automatically handles the conversion. In explicit casting, functions or commands are used to change the data type. For example, in Python, the int a function converts a value to an integer, while float converts it to a floating point number. If a user inputs 25 as a string, the command int a 25 would cast it to the integer 25, making it possible to perform arithmetic operations. Similarly, a floating point value like 25.5 could be cast to an integer using int 25.5, which would truncate the decimal part and result in 25. Casting is also useful when working with variables of incompatible data types in operations. For instance, if you have an integer and a float that need to be combined in a calculation, the integer might need to be cast to a float to ensure the result retains the necessary precision. This can happen implicitly in some programming languages, such as Python, where adding an integer, like 5, to a float like 2.5, automatically results in a float, 7.5. However, in strongly typed languages like Java, the programmer might need to explicitly cast the integer to a float to avoid compilation errors. In addition to converting between numeric types, casting can also involve converting between strings and numbers. This is particularly important in user-facing programs where input is typically provided as text. For example, if a program prompts a user to enter their age, the input would initially be treated as a string. To compare the entered age against a minimum age requirement or perform calculations, the string must be cast to an integer. Conversely, numeric data might be cast to a string for display purposes, such as showing a message like, "You are 25 years old," on the screen. The use of casting ensures that data is in the correct format for the task at hand, preventing errors and enabling smooth program execution. Both the assignment operator and casting are essential tools in programming, enabling variables to be used flexibly and effectively. The assignment operator ensures that variables can store and update values as needed, while casting allows data to be adapted to the appropriate type for specific operations. Together, these techniques provide the foundation for handling and processing data in programming, ensuring that programs are both functional and robust. Understanding and applying these concepts is crucial for any programmer aiming to create versatile and error-free code.